Quarter 4, Module 1, Testing Hypothesis. Hypothesis testing is a statistical method applied in making decisions using experimental data. Hypothesis testing is basically testing an assumption that we make out of a population. So, hypothesis testing is, again, statistical method. Gamit ni sa inyong research puhon, especially quantitative research o sa inyong capstone sa last pang grade 12 ninyo. So, this is, again, you are testing an hypothesis. Basically, from the word hypothesis testing, testing an assumption out of your population. So, when you say hypothesis, it is a proposed explanation, assertion, or assumption about a population parameter or about the distribution of a random variable. Here are some examples of questions you can answer with hypothesis test. So first, does the mean height of the grade 12 students differ from 66 inches? So you can answer this one using hypothesis testing. Another one is, do male and female grade 7 and grade 12 students differ in height on the average? Another question na pwede matubag using hypothesis testing. Lastly, is the proportion of the senior male student's height significantly higher than that of the senior female students? So that's another question nga pwede ninyo gamitan or i-answer using hypothesis testing. So, daghan ni, again, pag mag-undergo na mo quantitative research. This is the reason why statistics and probability is a prerequisite subject sa inyong quantitative research. Again, prerequisite siya, meaning, pag bagsak mo ani, or meaning, para dili kay sakit, pag dili mo kapasar ani, pareha naman po noon, no? Pero mas okay ang pag dili mo kapasar ani nga subject, you are not qualified to take the practical research 2 or the quantitative research. So, kailangan ganin yun ipasaron. So, key terms and concepts used in test hypothesis. So, first is the null hypothesis. When you say null hypothesis actually is an initial claim based on previous analysis, which the researcher tries to disprove, reject, or nullify. It shows no significant difference between two parameters. It is denoted by H sub O. When you say null hypothesis, meaning ang assumption nimo na walay difference sa previous na data. So it shows no significant difference. Na ay difference posible pero dili nga na ka-significant, dili nga na kadako. So mao na ang null hypothesis. There is no significant difference. So mao na siya null, no, from the word no. So denoted by H sub O. While the alternative hypothesis is contrary to the null hypothesis, which shows that the observations are the results of real effect. It is denoted by H sub A. So, kung ang null hypothesis means no significant difference, sa alternative pod, there is a significant difference. Meaning, na ay change na nahitabo sa imong previous nga data sa karon nga data na. So, na ay nahitabo. Wanang alternative. There is na ay difference and significant pod iyang difference. Dako ang difference, kumbaga. So, ang notation pod is H sub A. Note, you can think of a null hypothesis as the current value of the population parameter, which you hope to disprove in favor of your alternative hypothesis. So, ang null hypothesis atong i-disprove, kumbaga, like sa mga experiment nga pareha ng fertilizer. So, ang null hypothesis diha, walay significant difference sa, let's say, height sa isa ka plant. So, ang alternative is katong na ay significant. So, ang null, mao to ang i-disprove nimo kay hopefully ang imong ginabuhat manggod is magbutang kag fertilizer para mas utaas siya, kumbaga. So, mao nito imong i-nullify, imuhang i-disprove ang alternative hypothesis. Then, hopefully, ang null hypothesis, hopefully, ang alternative hypothesis ang ang ma-accept, kumbaga. So, sa imong experiment. So, examples. Let's take a look at this example. The school record claims that the mean score in math of incoming grade 11 students is 81. The teacher wishes to find out if the claim is true. She tests if there is a significant difference between the batch mean score and the mean of the students in her class. Okay. Sa diring example, let U be the population mean score and X bar be the mean score of the students in the class. Meaning kaning 81 dere is ang population, school record ni. Meaning gikuha tanan ang score sa math sa tanang students sa grade 11, then the average 81. Tapos na isa ka teacher, let's say sa advisor lang, isa lang ka teacher, sa isa ka section lang, ang iya is gusto niya i-test na ay significant difference sa kanang average sa iyang mga estudyante. Posible mas dako pa og to 81 or mas baba pa to 81. So ang mu diha is the population mean, ang X bar is the mean of the score sa katong nga section lang. So you may select any of the following statement as your null and alternative hypothesis. Meaning ang point lang nato ani is unsaon pag formulate og null og alternative hypothesis. So in formulating null og alternative hypothesis, these are pwede nimo buhaton. So based sa situation, pwede ka mo ingon as your null hypothesis H sub O, the mean score of the incoming grade 11 students is 81. Meaning wala na usab kay 81 man ang population, 81 pod ang iyang sa iyang section pod. Or in symbol, pwede ra ka mosultig mu is equivalent to 81. Ang alternative nato is the mean score of incoming grade 11 student is not 81. Or mu is not equal in symbol, mapo ni in symbol. Sa research manggod, kailangan good words. Pero kung statistics lang, solve lang, pwede ra ka in symbol. Or other option, pwede ra pug ka. Kung gusto nimo mas kumpleto, the mean score of the incoming grade 11 student has no significant difference with the mean of her students, kumbaga. Or mu is equivalent to X bar. Pwede ra po, the mean score of the incoming grade 11 student has significant difference. For the alternative niya, tapos ang in symbol, mu is not equal to X bar. So these are possible formulations sa null, H sub O, or alternative na H sub A. So nga na mag-formulate og null hypothesis o alternative hypothesis. So here is another key term you should know. The level of significance. So unsa po ning level of significance? The level of significance, di ba we have discussed what confidence level. Unsa po ning level of significance? When you say level of significance denoted by alpha or kaninga symbol, refers to the degree of the significance in which we accept or reject the null hypothesis. So, degree of significance na i-accept or i-reject nato si null hypothesis. 100% accuracy is not possible. So, dili gyud nahulog, impossible si 100% in accepting or rejecting the hypothesis. The significance level alpha is also the probability of making the wrong decision when the null hypothesis is true. So, katong alpha nimo is, that's the probability nga mali ka og decide. Meaning, gi-reject nimo ang null hypothesis where in fact it is true. So, that's your alpha. Do you know that the most common level of significance, ang most common is 1%, 5%, or the 10%. This corresponds actually to your confidence level. When your confidence level is 99%, then your level of significance is 1%. Komplementary, ito tawagan na. Kung sa sila, kumbaga, hindi po matawag ng complementary. Ang point is, 99 si level of confidence level, 1%. Ang total ana nila actually is 100. So, kaning 5% nga level of significance, therefore, ang imong confidence level ana is 95%. While kung 10% pod imong level of significance, therefore ang imong confidence level na is 90%. So these are the common level of significance. Usually nagagamit aning 1% mga scientific studies, 5%, tapos kaning 10% mga social studies kanang dili kayo okay ra. Ang delikado mga is kaning scientific studies labi nag it entails life and death like medicine and all. So yun. Okay, take a look at this example. Maria uses 5% level of significance, improving that there is no significant change in the average number of enrollees in 10 sections for the last 2 years. It means that the chance that the null hypothesis H sub O would be rejected when it is true is 5%. So kung atong ikuan na sa normal distribution, na-dre si 5%, level of significance man niya is 5%. So pasabutan na ay 5% chance nga mamali kag decide na dapat ang imong nabuhat is gi-reject nimo si null hypothesis where in fact it is true. Dapat di i-accept to pero na-reject nimo. So 5% ang chance ana nga mamali imong decision. Next, here is another key terms you should know. The two-tailed test versus one-tailed test. When can you say that it is a two-tailed test and one-tailed test? When the alternative hypothesis is two-sided gani ang alternative hypothesis. In symbol, say for example, H sub A, mu is not equal to mu sub O. It is called two-tailed. But when the given statistics hypothesis assumes a less than or greater than value, it is called one-tailed test. In short, ang tan-aw na to ana is ang alternative hypothesis. Kay ang null hypothesis always equal man guna. Sa alternative hypothesis ta magtan-aw. Kung not equal gani, then it is a two-tailed test. Pero kung less than ang symbol, greater than, less than or equal to, greater than or equal to, then it is a one-tailed test. So mao ra toy bantayanan. Okay, here is some examples. The regular registrar believes that the average number of enrollees in her school is not the same as the previous school year. So, based on na situation, pwede na ito ma-formulate ang atong null hypothesis as mu is equal to mu sub O. Because ang sulti niya diha, not the same man. By the way, basta null hypothesis always gonna equal ganiton. Then sa alternative hypothesis, since ang sultin sa register is not the same, in symbol not equal. So since not equal ang gisulti dere, natay two-tailed test. So pag mag two-tailed test ta, katong alpha nimo, katong confidence level, level of significance nimo, i-divide 2 na nimo. Okay, duha two-tail man sa left tail o sa right tail. So nga na pod ang symbol. So two-tailed ni again because ang alternative na to is not equal. Asa pod gikan sa statement nga not the same. What about kani? However, if the school registrar believes that the average number of enrollees in the school year is less than the previous school year. So again, same gapon og alternate null hypothesis, equal gina siya. But our alternative, since na siya is less than, dapat magamit tag less than siya. Next, kung less than pod, one-tailed test na siya. And less than, diri siya sa left side sa imuhang normal curve. Sa imong curve, kumbaga alpha nimo. Dili na nimo i-divide to kay one-tailed raman siya. Left-tailed pod siya. Less than left. So nga na. On the other hand, if the registrar believes that the average number of enrollees in this school year is greater than the previous school year, then you will have your alternative hypothesis now. No, null hypothesis nimo same gyapon, mu is equals to mu sub O. But your alternative hypothesis is mu is greater than mu sub O. Greater than symbol because of the word greater than there. Tapos one-tailed siya. sa right lang pod. Kay greater than, sa right pod na siya nga part. So, yun. Right-tailed test po ni siya. So, ana ang pag-determine kung one-tailed test or two-tailed test ba siya. Next, illustration of rejection region. The rejection region, or also called critical region, is the set of all values of the test statistic that causes us to reject the null hypothesis. Meaning, rejection region, mga values na muhatag sa inyo ito ag prompt kung baga nga dapat i-reject nimo si null hypothesis. From the word rejection region. Dito ang mga values, pag nabilong dito imong value, then you conclude, you decide to reject the null hypothesis. While the non-rejection region, or also called the acceptance region, is the set of all values of the test statistic that causes us to fail to reject the null hypothesis. Meaning, pag ang imo ang value na belong dito sa non-rejection region, you should not reject the null hypothesis. So, motong bantayanan. While the critical value is a point or boundary on the test distribution that is compared to the test statistic to determine if the null hypothesis would be rejected. So, kaning critical value is the boundary between the rejection region and the non-rejection region. So, for illustration, naara na siya. So, say for example, ingani ang imong sitwasyon sa imong graph, kung i-graph na nimo, diri ang critical value kanang boundary niya. Ang diri nga mga values, babaan ni 1.5 padulong dito, under siya sa non-rejection region. While kung manubra na dito, mga 2, 2.5 and so on, under siya sa rejection region. Kung nabilong diri, you reject the null hypothesis. While kung naa siya diri ang value nimo, then you should not reject the null hypothesis. Kay non-rejection region mo na. So, example ta. Now, let us take a look at Sophia's first claim. Actually, ang claim ni Sophia, she assumed that the average online usage of her friends is the same as the global usage H sub O. This is our alternative this is our, kumbaga, null hypothesis, I mean. Ang null hypothesis, the same lang. Mao ang gusto niya. But, naay kuan nga mas greater. Ang sulti man gud kuan is mas greater na daw ang average online usage sa mga bata karon. Tapos, ang gusto i-prove ni Sophia nga walay na usab. Same lang. So, same lang ang iyang claim, under siya sa alternative, sa null hypothesis. So, katong ingon nga nay na usab, which is ang sulti po diri, later on makita na to, ang alternative hypothesis ani is greater siya. Mas dako ang time na ang online usage karon. So, based ani nga sitwasyon, she computed for the t-value using the formula. Illustration lang niya, wala pa lang kahit nag-discuss ani. So, nagamit niya ang formula, tapos i-come up siya 1.593. Given tanan, kabalo naman tanin mo solve. Test statistic, discuss naman nato ni, di ba? So, t, gikuha niya ang t-value nato, nakuha nato nga t is 1.593 because using the formula x bar, 152 minus ang mu nimo nga 142 given niya divided by 19.855 na sample standard deviation over square root of 10 ka friends niya sample size. So ni come up siya 1.593. Then kailangan nato mao na ni ang t value nato, computed t value. So kailangan nato ang critical value. Ang critical value makitan sa table. Di ba? Nag-discuss na po taon sa pamangita sa table. Ang gisulti dire is, di ba 10 ang sample size? 10 ang sample size, nara. So, since 10 ang sample size, degree of freedom na to kay 9. Tapos under sa ato ang T table, natay area in two tails and area in one tail. Nganong sa area in one tail ta? Because actually ang problem ani wala lang kayo ni na-discuss manggod. Ang problem gid ani is ang alternative ani is greater than ang online usage. So kay greater than man, so one tail siya. So mo ni, tapos 5% pod ang confidence, a level of significance. So ang intersection niya is 1.833. So comparing this time, plotting the values in your T distribution. So ang imong kuan, compute ang critical value mo maning boundary, di ba? Boundary sa imong non-rejection region o sa rejection region. While katong imong na-compute pag-solve nimong formula, mao tong imong i-test kung asa siya nabilong, sa rejection region ba siya or sa non-rejection region. Ang critical value nato is 1.833, somewhere here between 1.5 o 2. Duol-duol kay 2. So mao ni imong boundary. So to the right of your critical value is the rejection region. To the left niya is your non-rejection region. Then your computed value is 1.593. So unahan gamay sa 1.5. So kung tanaw na to, naa siya sa non-rejection region. Naaman siya diri nga side. Naaman siya sa left sa imuhang critical value. So since naa siya sa left, unsa na karon ang, so we can now conclude or decide, so the computed value is less than the critical value. So mao ni actually ang ato ang null hypothesis. The average online usage of reference is the same as the global change or global usage, while ang alternative nato, the average online usage of reference is higher than the global usage. So higher siya, so greater than, mao na nasa right ta, tapos one-sided or one-tailed ta. So the computed p-value is at the rejection region. So if you can see, nasa sa rejection region. So therefore, we fail to reject the null. We should not reject. So therefore, we should not reject the null hypothesis. So dili kadap kay naaman siya sa non-rejection region. So, do not reject the null hypothesis. So, kadto ang decision dapat nimo. So, yun. Another example. A medical trial is conducted to test whether or not a certain drug reduces cholesterol level. Upon trial, the computed z-value of 2.715 lies in the rejection area. So, kung atong illustrate, the computed z is naadari ang critical value na to somewhere here, tapos naadari si computed 2.75. So, klaro nga nabilong siya sa rejection region. So, based from that, our null hypothesis is the certain drug is effective in reducing cholesterol level by 60%. O ng null. Alternative natin is the certain drug is not effective in reducing cholesterol level. So based sa graph na to, since ang atong computed z-value is na belong sa rejection region, therefore, we reject the null hypothesis. HO in favor of HA. So, nga na mag-decide. So, another illustrative example, sketch the rejection region of the test hypothesis which the critical values positive or negative 1.753 and determine if the computed p-value of negative 1.52 lies in that region. So, kailangan daw tayo pa-sketch. So, kung mag-sketch ta, ang buhaton nimo is you draw a t-distribution curve kay t-test man eh. P-value man. Since there are two critical values, it is a two-tailed test. So, ang critical values niya are positive 1.753 and negative 1.753. Then we are asked to locate the critical values and shade the rejection region. So, nga ang itsura na niya. So, natay T-distribution, tapos 0.5. So somewhere here, atong negative 1.753 between negative 2 and negative 1.5. Tapos ang positive pod between positive 1.5 to 2. So mao ni atong mga rejection region. Then we now plot the computed p-value which is negative 1.52. So ang negative 1.52 umunahan lang gamay kang negative 1.5. So naa siya diri. Kumbaga kung atong i-plot siya 1.5 man na diri si 1.52. So kung tanaw na to, ang kaning mga shaded part kaning duha puro na rejection region. Rejection region. So nabilong siya karon sa non-rejection region. So since nabilong siya, we can now decide. Therefore, we fail to reject the null hypothesis. So we should not reject the null hypothesis. Nga na ang decision. So next topic is all about type 1 and type 2 errors. Okay, rejecting the null hypothesis when it is true is called a type 1 error with the probability denoted by alpha. And hypothesis testing, the normal curve that shows the critical region is called the alpha region. So, when you fail, kumbaga, ang point is, pag once you reject the null hypothesis, where in fact it is true, you committed a type 1 error. And that is denoted by your alpha. So, di ba natay, let's say 5% ang alpha nimo, nakay 5% chance na makakommit og type 1 error. Again, unsa tong type 1 error? Pag i-reject nimo si null hypothesis, where in fact it is true. That's type 1 error. Accepting the null hypothesis where in fact it is accepting the null hypothesis where in fact it is false is called the type 2 error with probability denoted by beta. In hypothesis testing, the normal curve that shows the acceptance region is called the beta region. The larger the value of alpha, the smaller the value of beta. So meaning kaning beta, katong non-rejection region nimo. So let's say 5% imong alpha. Pasabot ana, you have 5% chance that you will reject the null hypothesis where in fact it is true. While kung 5% ang alpha, meaning kung 5% ang alpha, 95% imong beta. So, kung 95% imong beta, meaning you have 95% chance of accepting the null hypothesis where in fact it is false. Kay dapat man gud kung false siya, i-reject pero gi-accept nimo. Ang diripod sa type 1 error, true siya pero imong gi-reject. So error na to, pero type 1 error and type 2 error. So again, the larger the value of alpha, the smaller the value of beta. So para masabta na siya, let's summarize this one. Okay. Null hypothesis, let's say ang null hypothesis na to is true. Say for example, true siya. But nagamit na o nag-experiment ra. Tapos ang nilabas sa atong experiment, do not reject. So meaning, true imong null hypothesis, tapos wala nimo gi-reject, then you have made correct decision. But if true imong null hypothesis good, but pag experiment nimo ang nilabas dito kailangan nimo i-reject si null hypothesis, then that is a type 1 error because possibly mali imuhang pagka-experiment or mali imong na-collect na data. So nakakommit ka og type 1 error. Na-reject nimo si null hypothesis where in fact it is true. Okay. What about kung false gyud imo ang null hypothesis? Di gyud siya tinuod kumbaga. dili ang tama nga situation is dili gyud tinuod ang kuan, ang null hypothesis. Let's say para mas concrete ta. Katong example sa usage. Internet usage. Balik ta diri sa true. Let's say tinuod nga walay kausaban. Diba? Mamato ang null hypothesis na to, walay kausaban sa usage sa internet. So, tinuod. Tapos, nag-experiment ka. Tapos, pag-experiment nimo, ang nakabutang nito is do not reject. So, wala nimo gi-reject ang null hypothesis. So, tama imong desisyon kay dili siya tinuod. Wala gi kausaban. Tapos, ang sulti dito is i-follow nimo si null hypothesis, wala gi kausaban. So, correct imong desisyon. But, let's say pag experiment nimo nagkuha kag data, pagkuha nimo og data, ni result dito sample ra man gud imo nakuha nga data. Let's say naka-timing ka, ang nakuha nimo nga mga data is kadtong mga addict na gyud sa internet, na timingan lang. So meaning muda ko gyud ang result, ma-reject gyud nimo si null hypothesis. So na-reject nimo si null hypothesis, where in fact ang tinuod dito is walay kausaban, pero gi-reject man nimo ang imong gi-reject ang null hypothesis, meaning gi-follow nimo nga naay nausab. Dako ang kausaban kumbaga. So error na to. Ano kaya posible na error? Posible na timingan lang ang imong nakuha nga sample is katulong mga addict ginagyud og internet. So that's type 1 error. What about kaning sa false? Say false. Dili tinuod, meaning nag-increase na gyud siya. So, mao na ang kuan. Let's say, ang tinuod nga sitwasyon is nag-increase na gyud tungod sa pandemic. So, pag conduct nimo og study, nagkuha kag data, then, ang na-consider is fail to reject. Ang nakuha nimo is nga mga sample is wala. Walay kausaban. So, meaning, wala nimo gi-reject ang null hypothesis. So, niingon ka, conclusion nimo nga, same lang ang usage. But where in fact, ang global gyud na naginausab. So posible ang nakuha pod nimo ani nga data nga sample katulang yung wala na usab pod ang data. So type 2 error to siya. But kung gi-reject nimo siya, tapos meaning kung rejected ang null hypothesis, so meaning na inausab. Mo-coincide ra pod siya sa tinuod nga sitwasyon nga naa ginausab kay false man ang null hypothesis. So ing ato ang type 1 error o type 2 error. So again, type 1 error kung once i-reject nimo ang true nga null hypothesis. While ang type 2 error is wala nimo gi-reject ang false nga null hypothesis. So, let's have an example in real life. So, kani. Brian is starting his own food cart business and he is choosing cities where he will run his business. He wants to survey residents and test at 5% level of significance whether or not the demand is high enough to support his business before he applies for the necessary permits to operate in his selected city. He will only choose a city if there is strong evidence that the demand there is high enough. We can state the null hypothesis for the test as ang null hypothesis na to is the demand is high. So mo na ang null, high kay kumbaga high ang demand diya. So ang alternative ana is dili siya high. So kato. So question, what would be the consequence of type 1 error in this setting? So what if nakakommit siya type 1 error? Kung sa ganitong type 1 error again, ang type 1 error is i-reject nimo Pero in fact, it is true. So, true nga the demand is high, pero wala ka ni tuo. Kumbaga mo, itong type 1 error. Tinuod actually nga the demand is high, but based sa imong experiment, ang result man gud sa experiment nimo or sa imong statistical nga pag-test, dili high. So, unsa ang consequence ato? First, he doesn't choose a city where demand is actually high enough. Second, he chooses a city where the demand is actually high enough. Or third, he chooses a city where the demand isn't actually high enough. So, asa diha ang possible consequence sa type 1 error. Again, sa tong type 1 error, ang type 1 error again is i-reject nimo nga true siya. Muga dili nimo ni tuhuan ba? Pero in fact, true ni. True gid siya nga the demand is high. Pero wala nimo gi tuhuan. So asa dito? So basically this kaning 2, he chooses city where the demand is actually high. So meaning ani, he chooses the city tapos high man. So gi-follow niya. So dili ni error. Gipili niya to actually high man gyud. So this is a correct decision. Third, he chooses a city where the demand isn't actually high enough. This is a wrong decision. Kaya gipili niya pero dili high. Ang first pod, he doesn't choose, wala niya gipili pero actually high. So again, ang type 1 error, true ang ato ang null hypothesis. So, which is ang null hypothesis na to is high enough. Kung tanaw na to, dapat high enough siya. Diri man gud isn't high enough. Ang third na to, false ato ang alternative hypothesis diri. So dili pud ni mao. So ang answer ani is actually kanang first statement. Kani siya. Because ang type 1 error true ni ang atong null hypothesis. The demand is high. Mao man ang null hypothesis na to. Pero wala niya gi-choose. So type 1 error siya. Actually, this is a kaning number 2 is a correct decision eh. Correct decision. Ang kani, he chooses city where the demand isn't to. The demand isn't actually high enough, meaning false ni siya. False man eh. Kung kani, gipili niya ang false. Actually, this is type 2 error. Kani ang type 1 error. Yung type 1. Wala niya gipili ang city na actually high ang demand dito. That's type 1 error. Ang type 2 error is gipili niya ang city na dili gyud actually high ang demand dito. So, but ang question is type 1 error. So, ang answer is kani. Next. Okay. Na-answer na po na ko. So, kana type 2 error naman po ta. So, mo na ang type 2 error. Kay ang type 2 error, dipili niya, tapos false actually ang atong null hypothesis. Pero gipili niya. So, that's the type 2 error. And lastly, what is the probability of type 1 error? Murag gihatag to sa problem. So, nara. Level of significance is actually, mao na to imuhang type 1 error. So, 0.05. Kani. So, mga answers ani kani kana. Yun. So, that's all about Module 1, Testing Hypothesis. Thank you and see you next session.